Hello once again. Welcome to our final unit of the school year, the radicals unit. Today we are going to be talking about imaginary numbers and radical exponents. Our objective for today is to be able to find square and cube roots, use rational exponents, and work with imaginary numbers. So the first thing that we have to go talk about today is what a square root and a radical are. So a square root is a number which multiplied by itself gives you that original number. A radical is the name of the square root symbol. So for example, the square root of 81, 9 times 9 can be 81, so the square root of 81 is 9. The square root of 25 is 5. The square root of 225 is 15. And the square root of 93 is something that we can't figure out exactly perfect, but we can type that in on our calculator. So when we do that, we can say the square root of 93 is roughly 9.6. And that is not the exact square root, but it's pretty close. So 9.6. Next up, we have to talk about what some inverse operations are. So the first thing we have is squaring. The inverse of squaring something is the square root. What's that look like? Well, that looks like right there. 5 squared equals 25, and the square root of 25 is 5. Next up, we have cubing. The inverse of cubing is the cube root, and that is 2 to the third power is 8, and the cube root of 8 is 2. Next up, we have something raised to the fourth power, and you can pretty much pick up how this works all the way until we get to raising something to the fifth power. You could go higher, but we don't really do that too much in Algebra 1. After that, we're just going to go ahead and practice simplifying some of these. So the cube root of 64 is going to be 4. The fourth root of 1 is 1. The fifth root of 100,000 is going to be 10. The third root of 27 is going to be 3. Fourth root of 16 is 2. And the fifth root of 0 is 0. Next up, we got to talk about rational exponents. They are basically the same exact thing as saying that something is raised to a certain power. So 49 to the 1/2 power is just like saying the square root of 49, which the square root of 49 is 7. 64 to the 1/3, that's like taking the third root of 64, which is the same thing as saying 4. The fourth root of 1 is the same thing as saying 1 to the 1/4 power, which is just 1. So nothing too crazy, just a different way to represent it there. Next up, we got to talk about imaginary numbers. So imaginary numbers are numbers that we cannot find the square root of because we cannot find the square root of a negative number. So this circle right here basically lets us know if, when we do this, if we get a remainder of certain things, it will help us to figure out what these powers are. So to simplify these, we do I to the 5th power, and we say 5 divided by 4. 5 divided by 4 is 1.25. And the remainder here is 0.25. So it is simply going to be the square root of -1, which is simply, so your final answer there would be the square root of -1. So how this works is we have a, right here it's 0.25, here it's 0.5, here it's 0.75, And here you won't have any remainder at all, so it'll be a 0.00. And you can basically go off of that. So for example, if we do 8 divided by 4, 8 divided by 4 is 2, or 2.00. If we look back on our chart here, the 0.00 gives us a answer of 1. We do 18 divided by 4. If we do that, we get an answer of 4.5. The 0.5 is our remainder here. So if we look back on our chart, 0.5 gives us an answer of -1. The final slide we have to look at here is how do we take the square root of negative numbers that are perfect squares. And it's really not too bad. All you do is take the square root and make an I at the end. So the square root of 25 is 5, but our answer is imaginary because we can't take the square root of a negative number, so we say 5i. The square root of 4 is 2, so it's a negative number, so we say 2i. The square root of 1 is 1, so it's 1i. We don't have to say 1i though, so we just leave it as I. That's it for our lesson here today. I will see you guys shortly.